What are the intensities of sound waves with sound intensity levels of 46 decibels and 103 decibels? To start, we will start by saying our knowns and unknowns. For question A, our knowns are the sound intensity level, which is 46 decibels, and the threshold of hearing, which is 1 times 10 to the negative 12 watts per meter squared. Our unknowns are sound intensity. To do this problem, we need the equation beta equals 10 decibels times log base 10 of sound intensity level over threshold of hearing. But we are not asked to find the sound intensity level. We are asked to find the intensity of the sound waves. So we are going to use our knowledge of logs to transform this equation into the equation that we need. So we need to isolate sound intensity. So we will use the law that log of b base a is equal to x, which is equivalent to a to the x equals b. So using this knowledge, we can now transform this equation. So using this, we can see that the a and the 10 are equivalent, so we're going to be raising this part of the equation to 10, and we're going to set that equivalent to what the log is acting on, b, which is intensity over the threshold of hearing. Now we can isolate intensity by multiplying both sides by threshold of hearing, and we come out with this equation here, that I is equal to threshold of hearing times 10 to the beta over 10 decibels. And now using our knowns and our unknowns, we can solve this problem by plugging in our threshold of hearing times 10 to our sound intensity level of 46 decibels divided by 10 decibels. And we get 0.00004 because the decibels cancel out and sound intensity level is in watts per meter squared, and this simplifies to 4 times 10 to the negative 8th watts per meters squared. Now for part B, we are going to list our knowns, which is, again, the sound intensity levels, which in this part of the problem is 103 decibels, and the threshold of hearing, which is 1 times 10 to the negative 12th watts per meter squared. And we will list our unknowns, which is still the intensity of sound waves. Now we're going to use that same equation that the sound intensity level is equal to 10 decibels times log base 10 of sound intensity level over the threshold of hearing. And we're going to use our same derived equation of intensity of sound waves is equal to the threshold of hearing times 10 to the sound intensity level divided by 10 decibels. And we're going to plug in our knowns and unknowns again. So the intensity of sound is equal to the threshold of hearing, which is 1 times 10 to the negative 12th watts per meter squared. And that times 10 to the 103 decibels divided by 10 decibels We're going to plug that into our calculator, and we get I is equal to 0.019952, and that simplifies to the intensity of sound waves equal to 2.0 times 10 to the negative 2 watts per meter squared. And just to check our work, we're going to see that 46 decibels is quieter than 103 decibels, and that 4 times 10 to the 8th watts per meter squared is smaller than 2 times 10 to the negative 2 watts per meter squared.